All right, back in Desmos right here. I discovered something cool when I was in class earlier today, and I wanted to share with you guys a little bit because you might be able to sort of see how these functions transform without having to do like the equation of a line or write an actual equation. So I'm going to start with a basic function. I'm going to do a basic quadratic function. I'm going to type it here in Desmos. Feel free to go along with this. I think this would be a good exercise for you all to try to maybe practice some of these a little bit. So we're going to type in f of x equals x squared. Simple quadratic. Did one of these in class the other day, but I figured we would sort of see how it works. So we know that f of x equals x squared. Okay, and that's just the function that I chose because I think the quadratic's kind of easy to see. All right. So let's say we want to do just a vertical reflection. Okay, a vertical reflection. So a vertical reflection go over the x-axis. All that's going to be is negative f of x. Okay, so negative f of x right there, bang. Vertical reflection gives me that blue one right there. The next one we had was a horizontal reflection. All right, so a horizontal reflection, remember, was f of negative x. Let me write this down here. So this blue one, we have a vertical reflection. We can see it in the pictures right there. So on the next one, we're going to have horizontal reflection. So we're going to have f of negative x. See what it does? It gives me a green one smack dab right over our original one. So think about this for a minute. We have a quadratic right here, and we want to reflect it horizontally over the y-axis. Well, we see it's perfectly symmetrical right there. Perfectly symmetrical. Um, so here we have a horizontal reflection. All right. Now let's say we wanted to stretch it by a factor of 2. Stretch it by a factor of 2. So vertically stretch, I should say, by a factor of 2. That's going to give us 2 f of x. All right. And there's my vertical stretch. So this thing is vertically stretched by a factor of 2. Now, if we see this for a minute, we have a 0.11 right there, and the new point is 0.12. Okay, so the y values in this purple function right here are double the y values of the green function given an x value. So at this x value, the purple is double the blue. Okay, at this x value, same deal. Okay, that's a vertical stretch. If we wanted to vertically compress it, let's say we do a vertical compression by a factor of 1/3. Let's say we have f of 1/3 x. All right, so there's our vertical compression. Our green function is being shifted down, so that's a vertical compression. Okay. Next, let's try a horizontal. Okay, a horizontal thing. So if we were to do a horizontal, let's say we do a horizontal compression. So a horizontal compression, we're gonna actually, I messed that up. Vertical compression, we're gonna go 1/3. Sorry. It's late night on Friday. Tired. So we have a vertical compression right there. All right. So now let's talk about a horizontal stretch. So let's say we have a horizontal stretch of f of 1/3 x. Right. Again, the red one here is our original function, our original f of x. And here we're horizontally stretching it by a factor of 1/3. Okay, that's going to be a horizontal stretch. say we have a horizontal compression. Let's do a horizontal compression by a factor of 5. So let's say we have f of 5x. That's going to give us this green one right there, horizontal compression. And again, ladies and gentlemen, I have to emphasize that this red one right here is the one that we're manipulating. So this is our original f of x right here. Okay. And these are all the ways we're manipulating it down the thing here. Okay. So we have vertical reflection, horizontal reflection, vertical stretch, vertical compression, horizontal stretch, horizontal compression. Now let's talk about some translations real quick. All right. So now let's say we translate our red one up 5. Okay. So really that's going to give us f of x plus 5. Can't even see where that one went. So here's our red function right here. That's the original one that we had. F of x equals x squared. Check that. Sorry, that's this green one right here. So this f of x equals x squared is moved up by 5. If we want to move it to the right, let's say we move it to the right by 11 just to get it out of the picture here. So f of x minus 11 to minus 11, and it moves over to the right by 11. Now what's cool, we still have all these manipulations we have down here. Now what we can do if we want to, we could really have some fun and just change our f of x function to something else, and all the transformations should apply. So let's say instead of f of x equals x squared, let's make it a nice linear function of 4x plus 1. Here's our original function of 4x plus 1, which is this one right here. And then here are all the transformations that we did that would have been done off that 4x plus 1 function. I know it looks like kind of a mess, but you could type in your original function right there and do all the manipulations of the transformations below that, and it automatically kind of cranks that out. Okay, so again, we can go back to our original thing of x squared, and here's our original picture right here with our original one, which is this red one right here, and all the ways we transformed it all the way down the line right there. Okay, so it's kind of a cool little trick that I found just this morning in class. So maybe if you want to try it out and fiddle around with it a little bit, you could sort of manipulate these. So let's say, let's say we want to do something funky. All right. So we have f of x equals x squared. Let's say we want to do one of the 1C part 2 notes, right? So let's say we want to look at this, the f of 2 of negative 2x, right? And so we said on this one right here that we had a horizontal compression and a horizontal reflection, right? So we had a horizontal compression and horizontal reflection. Let's try it. So f of negative 2x, okay? And there we go. We have a horizontal reflection of this graph, which ends up being itself because it's symmetrical across the y-axis, and then it compresses by a factor of 2. Okay, let's look at the first one, 3f x plus x minus 4. So 3 stretched it vertically by a factor of 3, and then minusing 4 moved it to the right by 4. Let's look at it. 3 parentheses f minus 4 f of x, 3f of x minus 4. Bang. So this thing here was vertically stretched by a factor of 3. and it moved over 4. Now let's see how it's vertically stretched by a factor of 3. So let's just look at the rise over run here, right? So from 0 to 1, we go up by 1 over by 1, right? Rise over run, up by 1 over by 1. Vertically stretching by a factor of 3. From this vertex, we go up 1, 2, 3, and over 1. Okay, so that's what it means by vertically stretching it. Okay, so Desmos is a cool little tool. You know, you could just input whatever function you want up here, and then just type in how you change your f of x's. And as long as you call this thing f of x and you type these in correctly, these will automatically do the transformations on this original f of x, which I think is pretty cool. And you know, if you have time over the weekend, maybe you could try it out. No big deal, but just another tool you guys have in your toolbox to maybe understand this thing a little bit better. And that's all I have for you guys. I hope you have a terrific weekend. Sorry to bug you so much, but I'm just trying to make sure that we all have ample material and that we all understand it. I know it was kind of hit and miss this first week, and you know, we'll try to make things a little bit more smooth as we go forward. So, you guys, it's been a great first week, and really looking forward to working the rest of your year with you guys. And have a good weekend.